use the piece of paper that I have to work with me through this question again. To start with, what you see on the screen, let's say together class, is called a recurrence relation. Okay, what is a recurrence relation? With x1, right? With the x1 given to you, and using this recurrence relation, I can actually, write down what is x2. What will x2 be? 6 plus 5, which is 11. And then with x2, using the recurrence relation, it is going to be 11 and then x4 is x3, which is 16. I can still hear talking, and so on. So this is called recurrence relation. It is actually a relation that I can use it recursively to generate a sequence of numbers, right? Now, when you are told to solve a recurrence relation, what are you supposed to do? You are supposed to be able to write down the xn in terms of n. So solving a recurrence relation means you are able to actually write down an expression for the xn in terms of n. And because you have learned something previously in your lower years, you have recognized that the recurrence relation generated for me a very nice number sequence, which we call what? What's the name of the number sequence? The name of this number sequence is called a arithmetic progression. So apparently, right, this recurrence relation in 4a generates for you an arithmetic progression. And we have learned previously that in arithmetic progression, the Tn, remember, is a plus n minus 1 d. Okay, the good thing is, because a bit cramped here, oops. Nice. Okay. Right, because we have learned arithmetic progression very well, we could solve, so to speak, this recurrence relation very easily using what we already know, right? That is actually the n term is a plus n minus 1d. And then to answer this question, what is the meaning of converges? Or what does it mean to say that the sequence converges? To say the sequence converges means as n goes to infinity, the xn must go to a finite number. If this happens, we say the sequence converges to that finite number, right? And the finite number, if you like to, is called the limit of the sequence. I'll be rude. So tell me, as n goes to infinity, what does Sn approach? You got 3 seconds answer. Infinity. And therefore, do you say that it converges? Right. So in this case, this sequence Xn does not. Okay. If you have understood my first example, you have fully understood the meaning of recurrence relation. And you have fully understood what it means to solve a recurrence relation. It basically means to be able to write down xn in terms of n. That's it. What does it mean to say that the sequence converges or not? It basically means that as n goes to infinity, the xn goes towards a finite number. Full stop. So let's examine this recurrence relation. In this recurrence relation, right, you want to examine this very carefully. if you see a recurrence relation like this, like a yellow patch like this, okay? You want to be very quick to recognize that this is an AP, and based on your knowledge that you know of previously, you can solve for the xn of an AP quite readily. And the formula is A plus n minus 1d that you learned in year, which year? Year 2 or year 3? Year 4? So late? Can't be. Let's once again. Which year do you learn this? Year 2 or year 3? Okay, anyway, year 3, I think year 3. Alright, so how do you find this topic? Very easy, right? It's just a formula that can use recursively to generate a sequence of numbers. And then to solve that so-called recurrence relation means you're able to write down the xn in terms of n. And the next thing is, you want to ask, does the sequence converge? John, when I say a sequence converges or not, what do I mean? That as n goes to infinity, the xn approaches a finite number. Yeah, 150. Simple as that. So this is actually the essence of the whole chapter. You have understood it? Okay. Alright, that's great. Let's try another question. Let's try another question again. Okay. 4b again, 4b. If you compare the difference between 4a and 4b, there is a very subtle difference. In the case of 4a and in the case of 4b, Sean, what's the subtle difference? In the case of 4b, there is actually the green number there. There's a multiplier there. Whereas in the case of 4a, if you insist, that multiplier in front is actually a 1. That small difference makes it a world of difference, no? Like what? Chen Rui, what's the difference? 4b, right? Because of the subtle difference, right? 4b is I'll give you a chance to redeem yourself. Chen Rui, what is that? It's a GP, right? It's a GP. So you write down the first few terms, after a little while, you realize that this is a GP. And if I ask you to solve this recurrence relation, given that you now know that it is a GP, what would you write for xn? We learned in our young days, right? It goes to the first term times the common ratio, term number less 1. And by so doing, we have already solved the GP, or solved the recurrence relation. Vishwa, you're obviously watching video. Close the laptop. Okay, Vishwa, what is the next question I'll be keen to know about this number pattern? Does it converge, Vishwa? As n goes to infinity, will as n goes toward a finite number? No, right? Xn goes towards infinity. So therefore, does not. What is it? Get what? Okay, because when we were young, we learned this formula. Did you go through this process in your young days? In year 3, we learned the formula for GP. Nice, right? Right, easy, you know. So this chapter is quite easy because it's like revisiting something you already know when you were young. So in number 4a, we have the AP. In 4b, we have a GP. Are you happy? Okay. How about this? Let's hear from Aditya, sorry. Thousand apologies. I'm bad with names. Okay. What do you think this will be? Okay, give me two choices. A, AP, B, GP. No. You have two choices. A is AP, B is GP. So it's not GP. Aditya. So what is it? Also wrong. It's neither. You don't believe me, you try. It's not exactly a GP. Yeah, it is not exactly, but there's a GP element in it. Let's see again, let's see again. Let's see again. Your x1 is equals to 8. What is the x2? It is 3 times 8 plus 4. What is x3? 3 square times 8 plus 3 times 4 plus 4. Okay, let me pause for you to digest, to see if you agree with me. Anand, you're obviously having a fun time with visual. What is that? What's it all about? I can tell. Visual is a bad influence. Okay, John, if you understand what's going on, John, shh. What is x4? If I go on and on and on, tell me what is xn? Huh? Agree or not? And then you will have okay. Let's see. Let's see who. Okay. Let's see if you can read my mind. What I'm gonna write next. Do you remember when you were young in year 3, you learned a nice formula for the case of GP. In GP, you learn number 1, Tn is equals to number 2. You also learned this thing, when you were young. Sum of the first anthem of a GP. So if you do your arithmetic correctly, believe me, I'm going to do it mentally, Tell me if I'm wrong, okay? Vishwa, you're obviously distracting Anand. Check my arithmetic to see if I'm right. Are you writing on a piece of paper now? I can see that Bharati is having some doubts. Bharati, speak up. So what I've done here, class, I'm using your known knowledge. Using something that you already know when you were young. Okay, are you all happy? So all I've done is I've used the knowledge that we used before in lower years. Okay, move on. Does this converge? It doesn't converge. Okay? Let me ask you this question. No? What is the thing that causes it not to converge? The 3 to the power of n. The 3 to the power of n. Right? It does not converge. Okay? You find that when I solve 4b and 4c, if you look at 4b and 4c, okay, look at 4b and 4c, 4b and 4c. You see, it is not by chance, you know. If you look at 4b carefully, 4b, right? In front of the xn minus 1, there's a 3. That's why in your final answer for xn, you find that the answer is actually of this form, you know. There's a 3 to the power of n. It's not by chance. Because of the presence of 3 in the recurrence relation, you find that the solution to 4b carries a 3 to the power of n, and the answer for 4c also carries a 3 to the power of n. It's not coincident, you know. It's not coincident. In fact, you begin to realize that for such a recurrence relation, where xn is expressed as a multiple of xn minus 1, whether there's a plus 4 or don't have, the answer will always be in the form of this, no? And how do I know it is like this? Well, we went through the arithmetic in 4c, we find that it will happen. We went through the arithmetic in 4b, all the more is obviously there, like that. So if you begin to see that there's a pattern of solution, right? That actually the solution to this kind of recurrence relation will always take this form. If you live to believe, then you can solve this recurrence relation in another fashion, you know. How can we solve it, you know? We solve this by starting with this belief. We can start off with this belief. And how do we make use of this belief to get to the same answer, no? We will do it like this, no? Because we believe that the solution is like this, we can say that because x1 is given to be 8, I can then say that a times 3 to the power of 1 plus b must be 8. You know what I'm saying? And I can form a second equation using x2. How much is x2? x2 is 27. How do I know it's 27? So therefore, I can say that a times 9 plus b is equals to 27. Now, can you try to solve them simultaneously and tell me what is your A? Is it 27? Oh, I was just testing alertness. Thank you. 28. So now can you solve it mentally, the simultaneous equation, and tell me what would you get for A? By solving them simultaneously, believe me that your A will turn out to be equals to 10 over 3 and B is really minus 2, no? You check the simultaneous equation. Which means our class, we have two ways about it. The blue and the tedious way, or the pink and the easier way. To use the pink color, you need to have a great faith. What faith do you need? You need to believe that the solution looks like this. Is it hard to accept this belief? No. We went through 4b, we went through 4c, it works. And from 4b and 4c, we deduced in our mind that all solutions of such an equation, they must look like this. You know what I'm saying? They have to be. Okay? And our example for 4b and 4c will not converge, for sure. As we already discussed, the presence of the 3 to the power of n is damaging. Kiran asked, so do you prefer the blue or the pink? Are you for the blue, the hard way, or the pink, the easier way?
I don't understand why how you got the last line?
The pink or the blue?
How you got the last line?
This last line? Okay. Kiran, do you see that this number gives you a 2? And then when you expand an 8 and add to the 8 that thingy, if you expand, right? If you expand, it's a 2, right? 2 times this minus 2 times 1. And the 2 times this plus the 8 times the same, I'll get 10 copies. But the 3 power minus 1, I pull it out as a 1/3. Then it becomes 10 over 3. Nice, right? Okay. Do a class survey. Who is for the pink? Who is for the pink? It means you will use the pink method. Pink, you like pink. Yeah. As long as of this form, it is of this form, the pink works all the time. In fact, if you are very clever to notice something, if the number in front of the xn minus 1, if the number in front of xn minus 1 is not very nice, like 3, it will always diverge. Because your answer will have a 3 power n, it will always diverge. It will always explode. Right now. Then let me ask this question, under what circumstances do you think that it will converge? Right, like half. What else? Yeah, give me another example. What else would you have? 100. Anand, what example do you have? You are not listening, Anand. Outside your door, go. Colin, what other example do you have? 1 or 2 you use already. Right. And can you generalize it? Under what circumstances would it work? Less than 1 is not exactly correct. What is it again? Brilliant! That is Colin Chow, right? The guy who say minus 1 to 1. Right. You're right, okay? And because of this, the class will believe that in 4D it converges. Look, why do you think it converges? Look, why do you think in 4D it will surely converge? Because it's 1/5. And now, if you choose to use the pink color way of going about this, tell me, class, what is the first step? The first step is the belief. What is the belief? you need to have this faith in that the solution will be of this nature. Actually, nothing stops you from going through the hard way, going through the blue color way and arriving at your own answer. But because of our experience in this kind of questions, we know, we have great faith, we are very sure you look like the pink color. We have no doubts about it. Right? With this belief, we now want to form what? Simultaneous equation. And we say that A times 1/5 plus B must be 10. Jianhui, what is the second equation? Brilliant! Do you say 6? And class, just solve them simultaneously, you're done, So it's going to be 4/25, right? So it's 4/1. Is 25? Is A 25? Check for me. Is A 25? A is 25, and B is 5, and therefore our recurrence relation is solved in that xn is equals to you can check it out now to see that it works. You try x1, x2, x3, x4, x5 and find that actually it works. If you have understood up to this point, right, class, you have been very clever. You have learned how to solve recurrence relation. Nice, right? If you believe. Okay? So if you believe and choose the pink color way, your solution is that short. You can choose not to believe and do the blue color way and sweat it out, and still you get answer. For sure. Okay? For sure. You feel good about it? You feel very confident already? Okay. Which question will I hop onto next? Jiaming. Which question do you think I'll hop onto next? You are wrong. Next guess. Are you ready? Okay, for this recurrence relation, it is different from the one earlier. Jia Rui, what's the difference? The difference is, on the right hand side, apart from xn minus 1, there's also the xn minus 2. In the earlier one, you don't have xn minus 2, no? You only have xn minus 1. In the earlier one, the next term only depends on the term just before. But for this one, the next term depends on the term before and the term before. You know what I mean? The term before. So it depends on two earlier terms. That's the only difference. And to solve this kind of a recurrence relation, it's not so simple though. You can go and try this out, It's not going to be easy, You know what I mean? You're going to try this thing out, it is harder than what is going to be. Okay? So for such a question, right? For such a question, there are standard techniques to help us, The standard techniques is found, okay, so that you know where we take things from. Let me search the page for you. It's obviously found in chapter 5. I'll show you the page where it shows you all the beliefs. Okay, as I'm going to turn the page for you, let's see who can find that page in your notes, chapter 5, where you see all the beliefs. Okay, you see a page like this, no? (13) is it? Thank you. Abirud says page 13. So in our chapter 5, we have seen the first type I showed you, which is relatively easy. It's all the number 4, A, B, C, and D in the tutorial. We are actually looking to the second type, which is of this nature. And this page detailed for you the beliefs. The beliefs. And you find that this one looks very familiar to something you learned in calculus, I'm not sure how many of you actually have noted that when we did calculus last year, there was a part of the notes that we didn't learn. And that's in the part. Something similar to this. Okay, so what this page is trying to tell you, same thing, is the belief. If you want to see the proof for all this, it's also found in the notes, or just in later pages. But what I'm going to tell you today is, you want to actually believe what? That case 1, the solution will look like this, case 2 like that, and case 3 like this. Like it or not, class, you have to memorize this page, The earlier one, in question 4, not so bad, if you don't memorize it, But for this other one, you have no choice, but you have to memorize it, I also want to draw your attention to something, Class, this equation that you see right at the top right, you look carefully at it, look very carefully at it, okay? If I were to have a case where I plus a number here, the level of difficulty is totally different, I want to just highlight to you. Oops, I haven't drawn this. I'm trying to say that if I have a plus something here, right, the question becomes non-trivial. Just let you know. But we are not going to do this in our syllabus here. We are going to give you questions only up to here. Those that look like this, whereby this page will work. So you can be rest assured, that you'll be confined to this type. Okay, you'll be confined to this type. So I'm going to show you 9A. How I will make use of this page and do 9A. Let's play a game again. Let's see who can memorize this whole page, and then after you close the book, then when you do 9A, you can prompt me, You memorize it, Abirud? Let's see who has super memory power. Sometimes you have to learn math the bio way. Yeah. Bio I just memorized, no. I told before, right? I just memorized the whole book. I also memorized those diagrams, you know. Because I know when you go to the lab to do the lab test, right? It won't work when you look through the microscope, no. What I did was I looked through a microscope, I know, this is the picture of what. I wouldn't draw what I see, you know. I will draw what I see in the book, not in the microscope. Because the teacher want to see all the different things, ma. Sometimes you look through a microscope, you can't see one, you know, can't see it. For every reason, whether the microscope is faulty or your eyesight is bad, or you didn't put the enough solution to get the reaction, to get the bluish. So then I will just draw what I see in the book. Then you get good marks. And for physics, I always do one experiment at the one end and one experiment at the far end very accurately. I plot my graph, I draw one straight line, I just put other point. So I always finish my lab very quickly, and my lab is very nice. I always leave the lab very early, people wonder why. Because to do a lab properly, you got to do 3 times, 4 times, right? Not to get the average, to minimize all the systematic error and all the whatever errors. No? So I tell myself, do the first and the last very well. You just extrapolate. So I always finish my lab test very, very quickly, and I always get good grades. I know. Yep. Okay, so back to this page. Okay, I think they tell Miss Fong will faint, you know. Okay, so for this number 9a, we believe we want to follow the steps and say that the first thing I'll do is write down this thinking. The book gives a name to such an equation, you know. The book calls it the auxiliary equation. Some people call it the complementary, some people call it complementary auxiliary equation. I think there's a name for it, I just sit on my mind. But anyway, the first thing you do is write down this equation. The common mistakes is you forget to flush everything to the left hand side. You forget. You must flush everything to the left hand side first. Then you write down the statement, and then you get 2 solutions for m. You know what I mean? You get 2 solutions for m, and then you apply your faith, your belief. If you have 2 distinct real roots, it's case A. Case A says the solution will look like this. Change it. What is next? Change it is a very important thing to do tonight, you know. And that is you got call Chun Lei and tell him how to do this kind of math over the phone, you know. You're his best friend, you know. I noticed. You know why? Because every time you turn back to look at you, know, he just love looking at you. I don't know why. Huh? No, he always look at you. No, I noticed. Okay, change it. What's the next thing you do? You will say that 2a plus 3b is equals to x1. Next line. 4a equals to, and then you solve them simultaneously for a and b, you know. Okay, okay, times 3, right? So is a equals to 0, no? And b is equals to 1/3. So which means for this question, according to my calculation, therefore your xn is equals to 1/3 3 to the power of n, you know. Let's check if it is right. When n is 1, it's true, it's 1. when n is 2 is 3, right? When n is 3 and n is 3, right? According to the recurrence relation, it is 5 times 1 minus 18. So it's minus, let me mistake. When it's 3, right? Oh, I made a mistake. When it's 3, right, it's 15 minus 6. So it's going to be 9. So try x3, is it 9? Yes, it is 9. You can try x4, x5, infinite. It works. So this chapter, right, if you put in a lot of faith on page 13, technically it's over and done. No? You're done with this so-called all the things you need to know about solving recurrence relation, you know. Then the next question that we will ask is, does it converge? And the answer is no, it doesn't. It doesn't converge. Bhuvan, are you very sad?
I'm very tired.
I can tell. Okay, one more question. You quite idea. Okay, one more question. I know you're very tired. No, very tired. Okay, one more question. 9B. If you do it all correctly, you can march out of the class confidently. But if someone among you can't do, we all stay in. Okay. Must be everybody can do it perfectly well. Then you march out confidently. Then I feel good as a teacher that I have done you this favor. I've given you knowledge that I can bring home and then redo it again, you know. Okay, everybody must be able to do it, you know. 9B. Dominic, do you understand what's going on, Dominic? Do you have your notes with you? You do? It doesn't look it. You were looking at those notes. Okay, okay. Okay, 9B. Let's do 9B again. 9B. 9B. So if you have memorized page 13, then 9A, B, C, D is a no-brainer, no? You just apply the MS. You just use the method of studying. You know, it's MSMD method. It's called monkey see, monkey do method. Yeah, if you have memorized page 13, it's just doing math the bio way. Let me know you're stuck, no? I'll gladly show it to you, no? I'm hoping that in your tiredness, you're able to master 9B. If you're sure you're obviously not doing it, I've given you a piece of paper for you to do, not to direct Anand to do it and you watch, you know. Do your own. Anand, don't be a slave to him, you know. Okay. 9B. If you can do 9B perfectly, I'll be very proud of you, you know. Hey, can I give you a piece of paper for a reason? It's not for bring home the phone to aeroplanes, you know, it's for a try. Okay. Now practice first, then go home redo it again from beginning. 9B. John, finish it? Sure. They're doing 9. Okay. Yeah, it's right. It's right. It's right. It's right. I think you're right, you know. Yeah. Give yourself 2 taps on the shoulder. There's answer key to check. To check answer. He looks good. Just turn the back. I don't know the answer, but you can turn the back of the tutorial. The answer is there. And I think your method is right. 9B, there's a tutorial answer key there. Just check to double check that you're right. Yeah, John did rightly, he wasn't confident, but he actually did correctly. He says m squared minus 4m plus 3 equals 0. 9B is a bit peculiar, see, because one of the answer is a 1, And that made people very uncomfortable to say that xn is equals to a plus b, which John did correctly, because he feel that it's short, that it seems to be a short of a term, you know, like the earlier one. Because in this case, it's 1 to the power of n, is it? 1 to the power of n is just 1, is it? John, is it correct? Good. Try 9C. Look, are you stuck? Look. You're good. James, you finished 9C already? Are you done 9C already? Yeah. There's a 9C also. You just memorize page 13, it'll do you a lot of good. The one that will be slightly harder is the 9D. You know? 9D. 9D is a complex number. After trying 9B, you should try 9C and 9D, you know, to just get accustomed to the page 13. So you finish 9B. You should try 9C already. Just try lah, very easy. Still early. 2 minutes, so I give 2 minutes to finish 9C. Before 40, you should end the 9C. There's an answer for the check, you know, behind.
Yeah, and then most suddenly like the class again to the idea.
Anyone start in 9C that you need help? No, bro, you finished 9C, yeah? 9D also. Jay, which question are you? Brilliant. 9D, just don't map the bio way. Yeah, just MSMD. MSMD now. James, you finished 9D already, yeah? John, which question are you, John? 9 donkey already, yeah? Yeah, just do math the bio way. You know, do math the bio way. What's not possible? You got to solve for the complex roots. For the 9D, right? 9D is worth the while to work harder a bit. It's going to be m squared minus 2m plus 2 equals to 0. M is equals to B squared minus 4AC. So you get 1 plus minus I. So your R in this case is root 2, and your E is actually pi over 4 or so choose your R to be equal to root 2. See your R, right? See the R as root 2 and see the theta as pi over 4. And then you believe is R to the power of n A cos pi over 4 plus B sine. The arithmetic is harder because it involves trigo, but it's the same thing, you know. Did I make a mistake? You see carefully, did I make a mistake? Did I make a mistake? Not look carefully. Let's see who can spot the mistake. What mistake did I make? Right. There's actually an n here. Okay, let me write now. And then the same thing goes. Just form simultaneous equation and you're done. And now, yeah.